Hello, everyone. This is Elisa Baum, GridGain's Director of Product Marketing. We'll begin in just a moment, but first I'd like to conduct a bit of housekeeping. Could you please raise your hand using the hand icon located in the GoToWebinar control panel to let me know if you can hear me? Let's see here. Can everybody hear me? I see hands. Thank you very much. Next, during this webinar, you will be on mute, and should you have any questions during the discussion, please enter them in the questions field within the control panel. At the end of the webinar, we'll take time to answer as many questions as possible. In addition, I'll make sure that everyone gets a recording of this webinar and the slides within 48 hours. I would like to thank you for attending today's webinar, Modernize Your Legacy Data Warehouse with GridGain and Apache Ignite, or The Data Warehouse is Dead, Long Live the Data Warehouse, being presented by Rachel Pedreschi. She's our lead solutions architect, and with that, I will turn the floor over to Rachel. Go ahead, Rachel.
Hello, good morning, good afternoon, good evening, depending on where you are in the world. As Elisa was so kind, my name is Rachel Pedreschi, and I am an architect here at GridGain Systems. And I did actually change the title of the webinar on her, so apologize for that. But I thought this was a fitting title, as it's been. I've been in data warehousing since 1997 myself, and ever since that period, people have been decrying the end of the data warehouse, but yet it still lives on, and it lives on in new and wonderful ways. We're going to be talking about that a little bit today. I actually am much better in person than I am over the phone. So if you have questions, please do not hesitate to ask them. I actually have it on my screen, and when questions show up, I can address them at that point, or if I think that's going to be coming up later, or if it makes sense in a different spot. So, please feel free to ask questions, and thank you very much for coming. So, first off, a little about myself. Oh, actually, first we're gonna do the appropriate. Hey, we're doing a presentation, so I'm going to tell you what I'm going to tell you, and then I'm going to tell you, and then at the end I'll probably tell you what I told you. But first off, we're going to start with reviewing 3 common type of data warehouse architectures. So for you data warehouse vets out there, some of this might be a bit of review. For those who are not who don't know much about it, we're just going to go through some just at a high level. We're going to then talk about why is it time now for in-memory solutions, what has changed, what is the market forces and the drivers. We're going to then talk about what Apache Ignite is and GridGain. And then last, we're going to discuss how Ignite fits into these data warehouse architectures. So hopefully I will leave you with 3 reference architectures and where you could put Ignite in your current data warehouse. And then also what's next, so where to go for more information. So first off, as I mentioned, I've been in data warehousing since 1997. I was a data warehouse architect for a while at a company called Vail Resorts, and my job there was to take a point-of-sale system, enrich the data, and create a data warehouse or a reporting database for my marketing clients who are going to be using Cognos. So looking at this slide here, it was the initial scope was very much like the very top layer, where we had an application, we were moving the data into a data mart, and then we were going to be doing reporting and analytics off of it with Cognos. Very quickly, though, that model changed, and all of a sudden I had 32 different data sources to deal with. So not only did I have a point-of-sale application, but I had hotel information, and a lot of that came from mainframes. So I had text files. I had enrichment data from with Prism codes. I had just tons of data, and I had to figure out how I was going to take these data sources, put them into some type of schema that was going to be able to be accessible by the Cognos front end. And this was turn of the century-ish, so 2002, just to give you an idea of what tools I had available to me. But in general, that data mart was a star schema. or a snowflake. If you're not familiar with those terms, they are denormalized forms of third normal form that make reporting easier. And but the big problem was trying to get the data out of the systems and manipulate it to put it into my data mart. And for those who are familiar, this term is called ETL. It means extract, transformation, and load. And there's tools out there that will help you do that. I actually used Essential at the time, and a lot of Excel, and a lot of queries. You know, a big kind of mismatch of a bunch of different codes. And for 32 different data sources, this took me 10 months to put all together. And mind you, it was just me. But typically, ETL, especially for even for small projects, takes a lot of time and money. There's a number of studies that's been done that even at the enterprise data warehouse level, where you're taking data from a number of different applications, trying to meld it together like I was, and put it into, you know, a larger form called an enterprise data warehouse, it takes even more time and money. And I think I remember reading a Gartner report at one point that this was going to take 18 to 24 months from inception to the actual rolling out of an enterprise data warehouse. And to think about that, you go, oh, 18 and 24 months, you know, that's a project. But if you think about what the customer's requirements are that were driving the needs of the data warehouse, even in your own business, are you asking today what the same questions that you were asking 18 to 24 months ago? Or have they changed? Has your business drivers changed? Has the macro environment around you changed? And this is what people were running into, is over and over again, these ETL processes, even though I've simplified them down to, you know, little arrows on the screen, were just making it prohibitively difficult to get data warehouses implemented. And they had a very high failure rate. Again, then over on the right-hand side was reporting and analytics. There's a lot of tools out there. There was Cognos, there's Excel, there's now Tableau, MicroStrategy. There's a number of different options out there. And customers were becoming more and more sophisticated, and as soon as you gave them some data, they wanted more. So all the work that you did to get the data into a usable format in your data warehouse usually ended up not being useful at the end. There was, so over the years, a number of different database companies started up. I actually worked for Redbrick a long time ago, but there was a number of others. I have a few of them listed here, of analytic databases that made these data warehouses more faster and more scalable, and hopefully provide more value to the end user. Because at the end of the day, if your data warehouse didn't answer your customer's needs, it's not really all that useful. But the issues still existed, even with these wonderful analytic databases, that you had to do this ETL work, and it was still taking time and money. And there was more and more data being generated. So now we're moving into web applications and mobile applications, IoT. There's data being generated at an enormous rate. And none of these analytic databases were either too expensive or too difficult to maintain, to manage, and to grow, that they couldn't handle kind of this influx of data. So they were definitely not the unicorns that everybody was looking for. The unicorn that people were looking for actually came in the form of an elephant. And that, if you haven't heard of this before, Hadoop. So you've either been living under a rock or you're completely new to the data warehousing space. But Hadoop seemed to be the answer to some of these problems. Hadoop was developed by Doug Cutting. It came from the Nutch project. And really at the core of Hadoop is it's HDFS. It's a file system that allows you to distribute data amongst a number of machines, store it in and store a ton of data. And it's a NoSQL data store, so you didn't have to model it. The schema wasn't on write, the schema is on read. So you could just sort of take data from any source and dump it into Hadoop. And I would have to say that in my case at Vail Resorts, this would have been really, really useful. So instead of I would be able to speed my time to my customers, if I could give them some place that just all my 32 data sources were sitting in whatever format they were, and allow them to do some sort of exploratory analysis. And the way that that's changed over time is we now have a concept called a data lake. And the data lake is typically implemented in Hadoop. So you still have the whole idea of taking data from an application, doing your ETL, putting it into a data mart. But it takes a lot less time and a lot less money to take your data out of your sources and just dump it into a data lake. From there, you can do what I like to call, and it's called in the industry too, extraction, loading, and transform, so ELT. So after all this data in various formats are stored in your data lake, you can do exploratory data analysis using a number of different tools out there, some that are in the Hadoop ecosystem, some that are outside, like R, to figure out what data that sits in your data lake that is being stored very cheaply is useful. And from there, you can spin out your data marts and do your reporting and analysis. It speeds the time. It allows you to collect more data. You don't necessarily have to decide what data is important to you at the get-go. Gives your users the ability to access data that they wouldn't have had, that they might have had to wait for as it was cleaned and processed and put it into an enterprise data warehouse or a data mart format. So for the most part, everything about Hadoop solved a lot of the issues that the enterprise data warehouse was facing. But one thing that Hadoop is not, its mascot is not a jackrabbit. It is not fast. If anybody's used it in the past, it could take up to a minute to spin up a job. And but the data that is stored in Hadoop is incredibly valuable. You have all the clicks from your user system, for example, or you have every piece of data from your IoT. Having all that information at the time that you're interacting with your user can be extremely valuable. But Hadoop is not fast. It's cheap. It's easy to store stuff, but it's not fast. So a new type, and it's not necessarily data warehouse architecture, but a new type of system was developed, and it's called HTAP or Lambda. And what it does is it allows you to take either data that's in an application and bifurcate those writes. So send one set of writes up to your data lake or your data warehouse, to Hadoop, to a system of record somewhere, and send another set of writes to a speed layer that gives you a real-time view. Then, as your application requests, it will take the data out of batch, supplement it, and enrich it with the real-time data that is coming in at the same time, and it's placed into a serving layer. And that serving layer it can be something like Cassandra or HBase or any type of fairly fast database that your application can serve up, or you can grab data out to serve up to your users. You can also still do your reports out of your batch layer, or you can do reports out of the serving layer. So these Lambda architectures is sort of the next generation, or at least the way I see it, the next generation of data warehouse architectures. And you can have both, either one in your enterprise, and they live together very nicely. But the crux of all of this is, again, speed. The data is valuable that lives in batch, but people need their data quickly. So applications, mobile applications, web applications, speed is of the essence and scalability is the essence. So no longer do I have my 5 users back in 2003 that are running Cognos reports. I may now have 20,000 users that are inside of an enterprise who need access to data, maybe on a call center, and want to know my historical, what I've done historically, plus what I'm currently doing right now. Or I might have millions of mobile users who want to be able to make recommendations on what to buy. So speed has become the next stumbling block for data warehouse architecture, speed and scalability. How do we take something that is traditionally batch, traditionally large, traditionally slow, and make it fast? And so hence I want to introduce you to the Apache Ignite project. Apache Ignite has recently graduated to a top-level project in last year. Graduated up to top level, and it is an in-memory data fabric that has acceleration points for both Hadoop and Spark. So not only can it accelerate your relational database, it can serve as a system of record, and it can also accelerate Hadoop and Spark. But we're going to get to those in a little bit. Ignite is actually based on a product called GridGain, and GridGain's been around since 2007. It was decided to open source, donate the GridGain codebase to Apache in 2014, and from there it became the Ignite project, and has a very, very active community around it. But what's nice is that you have a project that has 10 years, almost 10 years of code behind it. Even though it made it to Apache in 2014, this is still a very, very mature code base with lots of different features. I'm not going to go through all the features today. We are just going to be touching on its integrations with Hadoop and Spark, but there is a lot more out there. Also, why this is a good time to talk about in-memory and speed is that the fact that the cost of memory is going down dramatically. And I want to point out on the left-hand side, this is a logarithmic scale. So the cost of memory and the new technologies that are coming from IBM, Micron, Intel, that even lower the cost of RAM even further, have made it more attractive to store more and more data in memory. Gartner says that that RAM is the new disk and disk is the new tape, and that the time for memory is now. And why is it important? Why is it faster? It comes down to physics, really. So when you have a disk-first architecture where you're taking all your data on and off of either rotational disk or SSDs or flash, you still have a very long access chain. You have to go from an API call, you have to demarshal, go to the OS, I/O controller, and then to disk. And your latency ends up in milliseconds. And especially if you're using spinning disk, which most Hadoop installations are running on because it's the least expensive option. Disks can only spin so fast. Otherwise you're going to get a little mini sonic boom in there, right? They only go so fast. With a memory-first architecture, you just all is an API call to pointer arithmetic, and that's it. So we're talking about latency in the nanoseconds or the microseconds. So the fact that the cost of memory is going down, plus the fact that in-memory architectures are so much faster and so much more scalable, means that it's now become available to a data warehouse architecture to do a lot more in memory than was previously available. So how does Ignite work? For the most part, it sits between your application and your database. It is a distributed in-memory data layer. And as an in-memory data layer, it stores the data in one of two ways. It stores it either as a key value or as a file system. The reason why we chose key value is that it's the least common denominator, and it makes retrieval and storage very, very simple. But what's important here to keep in mind is that when you move your data out of your database or out of your data store and into Ignite, that you are not having to change your data model at all. So different than some of the NoSQL databases out there that require, weird and strange things to do with your data model, you can leave everything the way it is. So all those years of data modeling and creating the right schema for your users, you don't have to touch. It looks exactly the same. It also provides in-memory indexes, so we have support for Lucene indexes and geospatial indexes, actually completely pluggable index structure, so if you have your own indexes that you want to implement, you can implement them in Ignite and they can be stored in memory. It's an always available architecture. So because Ignite's been around since 2007, memory was not as cheap back then, and it became essential to distribute a in-memory solution around a number of nodes. So even before these distributed databases were hot, before people were really sharding MySQL or using Cassandra, the Ignite already had to solve the distributed data problem. And so it's added features in order to maintain this always available. So the GridGain version of Apache Ignite actually has split brain support. So if you have a network partition and you have two sides, it helps you get through that. It has multi-data center replication, and even within the open source version of Ignite itself, you have backup copies of your data. So if one of your nodes goes down, you can have another version there waiting for you. And it's incredibly scalable, so as you need more data in memory, or you have more users or have more requests, it's easy just to add a node. This can be done in a cloud environment. It can be done on-premise. We'll be talking a little bit more about that in a little bit. But it's no longer gone are the days of saying, hey, I'm going to need to buy a whole new server with a new spec and migrate all my data over. Nope, you can keep your cluster the way it is, add a new node, it will redistribute the data, and you're done. Also, the scalability comes from you can use all the memory inside of your machines. So even though Ignite is a Java project, you are not limited to just on-heap memory. We can completely use off-heap memory as well, and we recommend it. There's also a tiered storage model, so if you do have data that overruns memory and you want to move it to flash or even to disk, that's available. So say your database underneath, so this isn't just for traditional relational databases like Oracle or Teradata. It will also work with NoSQL databases. And I actually spent the last 3 years working with Cassandra, and one of the big problems that we had was, one, that it wasn't fully consistent. It had an eventual consistency model. And two, it didn't have any SQL support. So you had to remodel your data. You had to change the way your queries worked, and you had to know what all your queries were up front in order to use Cassandra. Ignite actually removes that restriction. So you can even put Ignite between your application and something like Cassandra and now have full SQL 99 compliance, fully ACID compliant transactions. You could also be using Hadoop. So you could have native MapReduce, which we'll talk about in a little bit. So you have full in-memory indexes, you have full SQL 99 compliance, you have ACID compliant. You also don't have to have, you can do ACID batches, or you can do atomic transactions as well. Either one works. So that full level of control over your data, and there's no need to rip and replace. So you don't have to get rid of your old systems. They can all live in harmony, happy together, with Ignite running in between the application and your data sources. We also have a number of clients who use Ignite as a system of record. So even if some of these data sources don't exist, you could still just store the data in memory if you so choose. But for most data warehousing applications, you probably are going to have some type of underlying data source. So so Ignite comes with a Hadoop Accelerator, and the first portion of that is actually what we call the Ignite file system. And the Ignite file system can replace or sit on top of your Hadoop file system. It's completely pluggable with Hadoop. It has all the same APIs. It's completely transparent to your users. But what it does is it takes your Hadoop data, the data that's living on disk, probably spinning disk, in these big Hadoop boxes, and moves them into memory as the data becomes warm. You can also just use this all your Hadoop infrastructure directly with the Ignite file system as well. So you have the choice. You can either put Ignite on top of HDFS to keep data warm in a cache, or you can just use the Ignite file system. The other portion of the Hadoop Accelerator is an in-memory MapReduce. So so without having to make any changes to your MapReduce codes or your Hive queries, you can do in-memory MapReduce. So no need to keep going to disk. We can use Ignite compute grid capabilities to run code directly on the machines that store the data. It also bypasses a number of the Hadoop infrastructure. So you don't have to go to the job tracker, to a name node, to a task tracker to get to your data. You go directly from your user application through the Ignite client to the data node. And that data node can either be pulling data out of HDFS or can be living on its own. The Hadoop acceleration also includes integration with Spark using what we call Ignite RDDs. And I typically get asked, well, how is in-memory Ignite different than Spark? Spark does not actually have its own data store. You still need to pull data out of some sort of source system and create these RDDs. And yes, this RDD lives in memory, and you have your Spark application that talks to these RDDs. But once that application is done with that RDD, it's gone. It doesn't persist anywhere. So an Ignite RDD actually allows you to persist these RDDs in memory so you can reuse them. So you can have one Spark job working on an RDD, the second one, that same one, and you don't need to keep pulling that off a disk every single time, which speeds up the access patterns, the retrieval times incredibly. There's also a faster SQL with in-memory indexes that Spark can use, and you can use Spark SQL on top of these shared RDDs. So together, Spark works incredibly well with Ignite. They're set up to be a completely in-memory system that will speed up any type of machine learning or Spark jobs that you want to do. Clustering and deployment with Apache Ignite works in any environment. We're about a month away from being on the AWS Marketplace, doing the same thing with Azure, but we still have a number of clients that run us directly in AWS. Hybrid, of course, on-premise is fine. There's zero deployment, so this auto-deploys the code, full Docker support, and integration with Yarn and Mesos. So this will fit very nicely into most modern applications. But how does it work in our data warehousing architectures that we've talked about earlier? So pretty much have defined Hadoop makes an incredibly good data lake or data warehouse. Spark makes an incredibly fast and convenient and powerful front-end tool. There's also new tools like Tableau, which allow users to manipulate data on their desktops. definitely helps if that data is being able to be retrieved quickly. And this is where Ignite fits in. So Ignite will slip between your user applications and your data lake or your data warehouse, be it Hadoop or a relational database or a NoSQL database. It has a full JDBC and ODBC connections, so there's very little code change that needs to happen on the user side in order to access the data through Ignite and into Hadoop. And it's completely transparent to your users. They don't see any different because there's no need to change the model of the data. Ignite will just take all the data out of your data lake or data warehouse that is heavily used, hot data, move it into memory, and allow for incredibly fast access. We'll also store any type of RDDs, so your Spark jobs can reuse those RDDs. It will do native MapReduce, SQL 99, and as I mentioned before, full ODBC and JDBC support. For Lambda architectures, Ignite makes almost a perfect serving layer. So it can sit and give your application any type of data that it needs by reading it directly out of the your batch layer, again using ODBC, JDBC, native MapReduce. Integrate with Spark if that's your speed layer, or any other type of application to augment and enhance the data for your application in near real time. So for more information, our founder, Nikita Ivanov, is doing a webinar specifically about the integration with Spark and Ignite, and he's doing that on Wednesday, September 7th. That will include a demo of Spark and Ignite and how that works. GridGain's website has full documentation and customer use cases regarding this, and plus be sure to visit the Apache Ignite website for what's going on in the community, and ask questions, get involved, come to meetups. All the information for what people are doing with this in real life is out there. So that is what I have for you today. I don't have, let's see, I have one question. Let me take a look at it. Is there any other questions that I can answer out there? All right, well, if you do have any questions, you're free to hit me up on Twitter at Rachel Pedreschi, or send me an email, rachel@gridgain.com. Okay, I am starting to see some questions. Any performance benchmarks? We've got a lot of performance benchmarks. There's a number of them available on gridgain.com, but the one that I can talk to you about is the third largest bank in Europe did a benchmark with Ignite, and they needed full ACID transactions. And so they were able to get 1 billion full ACID transactions per second on a terabyte of data that was distributed over 10 nodes. And these 10 nodes were commodity hardware and cost about $25,000. This was a couple of years ago. But it's probably our best representation of how fast this goes. How does the next question? How does Ignite compare with Redis or VoltDB for data ingestion? First off, Ignite is not a database. You can think of more of it as a memory cache. So for data ingestion, as I mentioned before, we're talking about 1 billion transactions per second on a terabyte of data. That is not just writes but reads as well. And we might have some comparisons on our website as far as features go between those. Anyway, can I utilize Ignite through Oracle PL SQL? Not currently that I'm aware of, but let me check, and please send me an email with your email at rachel@gridgain.com, and I will find out how other clients are doing that. What is an efficient way to land cache data in Hadoop and vice versa, upload HDFS data to Ignite cache? Well, actually, the Ignite cache, you set it to bring the data out of HDFS or out of Hadoop at basically by how often it's used. So the hottest data will be stored in the cache, and then you set eviction policies on at what point do you evict old data for new data, and that's all set on the Ignite side. You don't Hadoop doesn't need to know about it. Ignite will go get the data that it's required out of Hadoop. Is there any other questions?
Hi, Rachel. It's Elisa. I just wanted to thank you for a great presentation. And just to answer one of the questions that was addressed towards me, everyone will get a copy of Rachel's slide deck as well as a link to the recording.